Welcome everybody to the MechNet Aerodynamics Laboratory. I'm Professor Kokins, and I'm going to be taking you on a journey today through the fascinating subject of aerodynamics. Aerodynamics is a really interesting subject to learn because of the fact that we're dealing with something we can't see, air. The only time, really, that we deal with air or see air is if we're going to have a bad hurricane and the local weather guy, wherever the hurricane is, decides to go stand out in the middle of a 120-mile-an-hour wind and tell us how dangerous it is to be there and nobody should be there. Well, then why are you and your entire crew there? Another point for another day. The first thing we're going to do here today is we're going to take a look at the properties of air. We have several different experiments to show you how these different properties visually can be seen. Instead of just talking about the different things as far as air having mass and weight, we're going to actually show you experiments to prove that it actually does happen. As we study the effects of aerodynamics, oftentimes people may wonder, why do I need to know about aerodynamics? I mean, I do. But really, if you think about it, especially in today's society where we're switching from fossil fuels to renewable energy sources, the study of aerodynamics is an extremely important thing. Take a look at your wind turbines. That's all aerodynamics and how those things work. Our next generation of wind turbines, as things get better and stuff, is going to require you as the engineers to design these new wind turbines to develop a sustainable energy. Also, let's take a look at your electric vehicles. They are extremely dependent upon aerodynamics because one of the major forces that slows the car down going down the road is this thing called drag. By studying aerodynamics, we can study ways of reducing that drag on the vehicle, and we'll make the batteries last longer. These are all good things. As we begin our study of aerodynamics, the first thing we're going to do is take a look at the airfoil that we have mounted here in this 2 by 7 foot test section wind tunnel. What we've done is we've done this a little differently than most folks in testing airfoils. Generally what you do when you test an airfoil in a wind tunnel is you just mount it in the center and you rotate the airfoil up and down and you take pressure readings to show how that affects the airfoil. We want to actually show you these things. So what we did is we mounted the airfoil on linear bearings. What that does is that allows the airfoil to physically move up and down in the wind tunnel. And we can actually see how the air flowing over the airfoil affects the airfoil and actually make this thing fly. For this experiment, I'm using this hand control so I can talk to you folks while I'm doing this. But actually, this can be controlled remotely via the internet by any teacher, student, anybody. You will be able to do the exact same things I'm doing from the computer screen. You will be able to control the speed of the wind tunnel with the slide bar on the computer screen, control the angle of attack, and then we'll have a video camera mounted on this so you'll actually be able to see the airfoil fly in the wind tunnel. All of these data screens are all using a graphical interface program called National Instruments LabVIEW. These LabVIEW screens were developed by Viewpoint Systems of Rochester, New York. Viewpoint has done an extremely good job in working with MechNet over the years to develop all these systems. What we're striving to do is do things a little differently in education. We're trying to make things more real. Instead of just talking about things, we want you to see how things actually work. What I'm going to do now is increase the speed of the wind tunnel. And what we're doing is making the airfoil actually fly. As I increase the speed of the wind tunnel, you'll start to see the airfoil begin to lift. As I change the angle of attack, you can see the airfoil go down as a result of that angle of attack changing. What we have done here is we have shown you two things: how the airfoil is affected by both the airspeed and the angle of attack. Both of these things will affect how much what we call lift is created with the airfoil.